Okay, so with this question, we are asked to find the concentration of a nitric acid solution based on how much of a barium hydroxide solution is required to neutralize it. I know I have 25 mils of the nitric acid solution, and I know that 15.7 mils of this 0.25 molar barium hydroxide solution neutralizes it. And so from that information, we can calculate what the concentration of that original nitric acid solution is. But the best way to start this calculation is really with a balanced chemical reaction. So I know that I'm going to have nitric acid, and it's going to react with barium hydroxide, and it's going to form water, and it's going to form a salt. And the salt comes from the double displacement reaction. So the positive ion switches anions, okay? So the hydrogen, the H+, is going to take on the OH, and that's where we get the water. And so the barium is going to take on the nitrate, and so we would get barium nitrate. Now you need to remember from Chem 1 that barium is a +2 ion, and so in a nitrate, the polyatomic ion nitrate is -1, so it requires 2 nitrates to balance the charge, or to neutralize the positive charge on the barium. Okay, so now that I've got the bare bones chemical reaction, I can balance it. So I've got 1 barium on the left, 1 barium on the right. Okay, and it's always best when you can, whenever it's possible, to balance the polyatomics together. So let's balance this NO3 as a unit. And over here, I have 2 NO3s, but on the left, I only have 1. So I can fix that by putting a coefficient of 2 out there. All right? And so now I've got 2 hydrogen on the left, and I've only got 2 hydrogen on the right, but I've also got 2 hydrogen over here on the left from these hydroxides in the barium hydroxide. So I've got a total of 4 hydrogen on the left, but only 2 hydrogen on the right. So once again, I can fix that just by putting a coefficient of 2 out in front of the water. And so now I should be balanced because I have 2 oxygens. Remember, I balanced this nitrate together, so I'm not going to mess with that. But I have 2 oxygens, and I have 2 oxygens. I have 2 plus 2 hydrogens, 2 times 2 hydrogens, so 4 hydrogens on each side. I have a barium on each side, and I have 2 nitrates, 2 times the nitrate, 2 times the nitrate on that side. So now my reaction is balanced. And that's important because it gives us the mole ratio between the nitric acid and the barium hydroxide. All right, so the next thing I need to do is I need to start my calculation, and remember that when you're doing a stoichiometry calculation, you always start with a number that you know that is not a conversion factor, all right? And you know that you have 15.7 mils of this barium hydroxide solution, and you know the molarity of that, so I can convert this volume into a number of moles of barium hydroxide using this molarity. So that's going to be my starting point. So I have 15.7 milliliters of barium hydroxide, and the first thing I can do is convert that into liters because I know molarity is moles per liter, so let's change this milliliters into liters. There are 1,000 milliliters in 1 liter. Okay, so that means my milliliters will cancel. And I know from the molarity that in 1 liter, we'll put that on the bottom, there's 0.250 moles of barium hydroxide. Okay, so now liters of the solution cancels. And so now I have my calculation currently in units of moles of barium hydroxide. Well, now I go to my balanced chemical equation and I say, well, I need 1 mole of barium hydroxide to react with 2 moles of nitric acid. So I set up that ratio here in the calculation. So 2 moles of HNO3 on top for every 1 mole of BaOH2 on the bottom. So now units of moles of barium hydroxide cancel. And so right now I have, if I were to generate this number, it would be in units of moles of nitric acid. And let's do that. So you punch all that into your calculator, and you get 7.85 times 10 to the minus 3 moles of nitric acid, HNO3. Right? Now, I haven't answered the question yet. The question says, well, what's the concentration of nitric acid? Well, that's pretty easy because I know that concentration is moles per liter. And so I know that the 7.85 times 10 to the minus 3 moles of HNO3 was in a 25 milliliter sample. So if I divide that number of moles by the volume expressed in liters, 25 milliliters is 0.025 liters, that gets us moles per liter, okay, which that is units of molarity. It's a unit of concentration. So I just do that calculation, and you get a concentration of 0.314 molar HNO3.